Hey class, this video is on applications of systems in 3 variables. We've already looked at applications of systems in 2 variables when we did the comparing two things, and we also did the how much of each type problems and the distance and rate problems. So this is going to be similar, except for this involves 3 variables. So also we're going to use augmented matrices to solve the systems of 3 variables. So if you have not first finished 2.3c, the one before this, on solving with augmented matrices, stop now and go back and do that, because you do need to know how to do the row reduced echelon form in your calculator to get your answers. But here we go. So write a system of equations and then use the augmented matrix to solve. So a theater group sold a total of 440 tickets for $3,940. Each regular ticket cost $5, each premium ticket cost $15, and each elite ticket cost $25. The number of regular tickets was 3 times the number of premium and elite tickets combined. How many of each type of tickets were sold? So first we have to define our variables. So we have X equals, and we have 3 types of tickets: regular, premium, and elite. So we'll do X equals regular, number of regular tickets, Y equals number of premium tickets, and we'll let Z equal the number of elite tickets. All right, then we were going to have 3 variables, so I know I'm going to need 3 equations. The first 2 equations are very similar to the how much of each type. We have a theater group that sold a total of 440 tickets. So that's our first equation, is our total equation. If we add up our regular tickets plus our premium tickets plus our elite tickets, we have a total of 440 total tickets. So that was our first equation. The next part comes from our cost. Our regular tickets cost $5, our premium cost $15, and our elite cost $25. Altogether, we sold $3,940 worth. So that's $5 per regular ticket plus $15 per premium ticket plus $25 per elite ticket. Altogether, those equal $3,940. So those are our first 2 equations. So that's going to be very similar to systems in 2 variables, the how much of each type problems. The third equation requires a little bit extra thinking involved here. What's a nice color that won't take up too much here? So this is our third equation. The number of regular tickets was 3 times the number of premium and elite tickets combined. So the number of regular tickets, X, actually I'm going to put that over here. The number of regular tickets, X, equals the number of 3 times, so 3 times the number of premium and elite combined. When you combine something, you add them together. So 3 times premium and elite. So that's my third equation right here. It goes with the pink highlighted marks there. So now I need to get it in the form X, Y, Z, and my constant. So I actually need to distribute this out. I'm going to get X equals 3Y plus 3Z. And then I'm going to have to move the 3Y and the 3Z to the other side. So I'll actually have to subtract 3Y and 3Z from both sides. So that's going to give me X minus 3Y minus 3Z. And if I subtract everything from the right, it's going to equal 0. I need that so that I can set up my augmented matrix, which takes the coefficients from each row, each letter, the constants at the end. So we have X, Y, Z, and then the constants. So my augmented matrix will be with the first equation, 1, 1, 1, 4, 40, and then 5, 15, 25, 3,940. Then it will be 1, negative 3, negative 3, 0. So using your graphing calculator, you're going to go in and edit your matrix to be a 3 by 4 and enter those values. Go back to your home screen, go under Matrix again, under Math, and choose RREF. It's the alpha B key of your Matrix A or whatever matrix you plug it into. And then hit Enter, and it's going to give you this one. The row reduced echelon form when you're done will look like this. And then remember that this is really my X, my Y, and my Z columns. So this tells me that X equals 330, Y equals 46, Z equals 64, which really means that I sold 330 regular tickets, 46 premium, and 64 elite. So once you get it set up, which will be the hardest part, plug it into an augmented matrix and use row reduced echelon form. Okay, through an example problem, because these distance and rate problems do seem to be giving us a little trouble, and we can solve it with a row reduced echelon form, so we'll give it a shot. So the passenger plane took 3 hours to fly 1,800 miles in the direction of the jet stream. Return trip against the jet stream took 4 hours. What was the plane's speed in still air and the jet stream speed? So I'm going to have X be the plane speed, and I'm going to have Y be the jet stream speed. I'm going to, over here, I know that distance equals rate times time. If I take the distance and divide it by time, I'm going to get what my rate will equal. So if I take that 1,800 miles divided by 3 hours, I get 600 miles per hour. That's my rate in the direction of the jet stream. So that is with the jet stream. Now, if I take 1,800 and divide it by 4 hours, I'm going to get 450 miles per hour. That's against the jet stream. So that is when you are against the wind. So the plane is working apart. So first you have X plus Y equals, so that means the plane speed plus the wind speed, or plus meaning that the wind speed is increasing the plane speed. So that means it's going to be going faster. So that takes less time. So it's the rate here, 600 miles per hour. Then when the wind is working against the airplane, X minus Y, it's 450 miles per hour. It's going slower. The air speed, the resistance is making the plane go slower. Okay, so then we can set up a row reduced echelon form. You can solve with elimination here, or you can set it up as 1, 600, 1, -1, 450. If you run row reduced echelon form of this, you'll get 1, 0, 525, and 0, 175. Which means that the plane speed was 525 miles per hour and the jet stream was 75 miles per hour. And that would be our answer for that. So just a quick review problem in there as well. Okay, so this one's back to 3 variables. A quilt maker plans to make 14 quilts this year from 113 yards of fabric. A small quilt requires 4 yards of fabric, a medium quilt requires 7 yards of fabric, and a large quilt requires 11 yards of fabric. She plans to make twice as many large quilts as small quilts. How many of each type of quilt should she make? So it's a how much of each type again. We have 3 variables. We have X equals, we have small quilt, medium quilt, or large quilt. So we'll let X equal our small quilt. Y equal the number of medium quilts, and we'll let Z equal the number of large quilts. So we got small, medium, and large. And again, it's how much of each type. So we know that they plan to make 14 quilts. So that's our first equation. All together, small plus medium plus large, I'm making a total of 14 quilts. And then we know that the small quilt requires 4 yards, the medium requires 7 yards, and the large requires 11, and we're using a total of 113. So the small is 4 yards of fabric per the small, 7 yards of fabric per medium, plus 11 yards of fabric per large, and I'm using a total of 113 yards. So those are my first two equations. Hopefully those are making sense. It's very similar to how much of each type with two variables. The third equation you have to read carefully. She plans to make twice as many large quilts as small quilts. So twice as many large quilts as small quilts. So I would do large quilts is going to equal 2 times as many small quilts. So twice as many large quilts as small quilts. So if I had made 4 small quilts, 4 times 2, I'd make 8 large quilts. So that's why I just make sure that I plug in a value to make sure it makes sense. And then remember, it does have to be in the XYZ order, so you're going to have to subtract that 2x over, and it'll be negative 2x plus z equals 0. But when you move it over here, you're going to have negative 2x. You're going to want to do 0y plus z and then equals 0. So now you're ready to put it in row reduced echelon, in an augmented matrix using the coefficients. So along the first equation, we have 1, 1, 1, 14. We have 4, 7, 11, 113. Then negative 2, 0, 1, 0. Put it in your calculator and find the row reduced echelon form, and that comes out as 1003, 0105, 0016. I had made a mistake when I put this in the first time. Instead of plugging in for 113, I had just typed in 13 and I got negative answers. And I knew it was wrong because I'm talking about how many quilts I'm making. So I can't have a negative number of quilts. So make sure you pay attention to what you're getting and make sure it makes sense. So that means that, remember, this is x, y, z. So x equals 3, y equals 5, z equals 6. Which means I'm making 3 small quilts, 5 medium, and 6 large quilts. There we go. All right, I have one more for you that's on an investment. So very similar, but involves investment. So you have $60,000 to invest. You want to invest money in stocks, bonds, and money market funds. They yield 12%, 8%, and 5% respectively. You want to invest the same amount in stocks as in bonds and money market combined. Your goal is to make $5,400 in interest. How much should you invest in each fund? So we have 3 types of funds: stocks, bonds, and money market funds. So those are our variables. Let's let X be our stocks, Y be our bonds, and we'll let Z be our money market funds. So I have a total of $60,000 to invest. So all together, when I put the money together between the stocks, bonds, and money market, I have a total of $60,000 to invest. Then I have stocks, bonds, and money markets yield 12%, 8%, and 5% respectively. So in that order. So the stocks are 12%, which is 0.12 per the money that I put in X. 8% is 0.08Y. 5% is 0.05Z. And I want to make $5,400 in interest. So since the percent is what you're earning in interest, that's the making the money in interest goes with this account, with this equation. Whoops. So you're going to set what you're earning equal to $5,400. And then the last equation comes from the sentence right here, which it says you want to invest the same amount in stocks as in bonds and money market combined. So you want your stocks account to equal the same as your money or your bonds and money market combined. Combined means you want them to be added together to have a total. And then you do have to move the y and the z over again. So it'll be x minus y minus z. And if you do that, you'll get it equal to 0 here. Then we take these values and very carefully put them into an augmented matrix. So 1, 1, 1, 60,000, 0.12, 0.08, 0.05, 5,400. So make sure you're not typing in 0.8 and 0.5. That'd be 80% and 50% instead of 8 and 5. Then 1, -1, -1, 0. Use your calculator to find the row reduced echelon form, which is 1, 0, 0, 30,000. We have 0, 1, 0, 10,000. And then 0, 0, 1, 20,000. So those seem to make sense. Plus they add up to 60,000. So, make sure that you didn't type in something wrong. These numbers here should add up to 60,000 because that's how much money you had to invest. You shouldn't get any negative numbers there. That doesn't make sense. This is X, Y, and Z equals. So that means that I want to put in $30,000 into my stocks. I'm going to put $10,000 into bonds. And then I'm going to put $20,000 into the money market account, which is basically a savings account, which earns the interest based on the market of the day value. So money market bonds are like savings bonds. Your grandma might have bought you some when you were young. And then stocks are like buying stocks in Apple, and you earn money based on how the stock is doing. So there you go. I think that is it for this one. Oh, there is one more, I guess, but it's already kind of set up for you. You can stop here if you want. You can continue to watch. I'll do it since I have this running here. Hopefully it doesn't get too long. A pet store receives a shipment of pet food at the beginning of each month. Over the 3-month period, the store received 1,770 pounds of dog food, 1,165 pounds of cat food, and 365 pounds of bird seed. Write the system and find the number in each of the 3 shipments. So I'm going to let my variables be X, Y, and Z, being the first, second, and third shipment. And then my equations are basically written for me here, except for that I know the total in dog food that was sent was 1,770. The total in cat food was 1,165. And the total in bird seed was 365. Just remember to make sure to change these percents to decimals when you're writing the equation. So the first equation will be all dog food, be 0.6x for 60% of x, 0.5y for 50% of y, and 0.5z for 50% of z. And that will equal the total 1,770 pounds of dog food. Cat food will be 0.25x plus 0.35y plus 0.45z, a total of 1,165 pounds. Bird seed, 15% for each, and then 5%, 0.05, so careful there, and 365 pounds of bird seed. So changing that into a matrix, augmented matrix is the word I'm looking for, look like this. So just be careful with your decimals, that you make sure you copy them down right, especially the 0.05 for 5%. Running the row reduced echelon form, you're going to get 1, 0, 0, 1,200, 0, 1, 0, 800, and 0, 0, 1, 1,300. So it asked me how many pounds were in each shipment. So that means that the first shipment had 1,200 pounds, the second shipment had 800 pounds, and the third shipment had 1,300 pounds. So that would be my answer. I went through that one kind of quick, but I feel like this video is getting long. Thanks so much for watching. Have a great